Ibon, welcome you all for today's video. Today I am going to explain electrochemical cells. So first of all, we are going to study electrochemical cells. We have to study what is an electrode, the definition of electrode and electrode potential. So today I am going to explain electrode potential. So let's move on to video. Stay with me. I am Hasanka Kalingwarachi. Okay, we will consider, imagine, this is a beaker. This beaker contains an electrolyte solution which is consists of M metal. Metal is M. Just imagine, metal is M, its oxidation state is N. So this is positive charged electrolyte, Mn plus solution. So this is neutral. This solution is neutral initially. Solution is neutral initially. There is another metal rod we have. It also consists of M. The metal is M. It also neutral initially. Okay, both are neutral. Now what will happen if we dip this metal rod in this solution? What will happen? So I am going to dip this particular neutral metal, which is neutral metal rod, in this solution, or just I dipped. Okay, now we will see what will happen. So this is metal M dipped in its own electrolyte solution. So this metal is same, both solution contain also metallic ions. This metal rod contain metal. So this is a solid, this is a liquid or aqueous solution. Okay, in this situation what will happen? You can imagine that. Now we are talking about the electrochemistry. The electrochemistry, the possible or preferable equation is we are using reduction equation. So what will be the reduction equation? The reduction will be this Mn plus electrolyte or ion will get n number of electrons from anywhere and it will convert into M, solid, here aqueous. Okay, what will happen? Just keep this in your mind. I will explain everything what will happen here. Okay, now imagine, we know that obviously the metal ion concentration or metal atom or anything, metal is very higher in this rod than the solution. අපි දන්නවා මේ රොඩ් එකේ තමයි වැඩිපුරම metal ion ඉන්නේ, atom ඉන්නේ මේ solution එකට වඩා. So there will be a reaction between these two phases, solid and liquid aqueous phase. What will be the reaction? If we consider this reduction equation, Mn plus will get 2 electrons. These electrons came from where? What do you think? This electron will come from this rod. Why? We know in metal contain metallic lattice. අපි දන්නවා ලෝහ හැදිලා තියෙන්නේ ලෝහක දැලිසකින්. Metallic lattice. Metallic lattice mean the positive charge metal ions is dissolved or it is dipped in or it is surrounded by sea of free electrons. Free electron sea. Free electron sea. This is the structure of a metallic lattice. අපි දන්නවනේ ලෝහක දැලිසක් කියන්නේ ඉලෙක්ට්‍රෝන ජලාශයක ගිලුණු ධනාරෝපණ. So cations are dipped in or immersed in an electron sea. This is the structure of a metal. So this metal also, its structure also the same as other metals. So what is the thing you have to know? This metal contain number of free electrons. However, this metal rod is neutral. Why? Because to neutralize this electrical negative charge, there are sufficient amount of or equal amount of cations or positive charges. අපි දන්නවනේ මේ ලෝහයෙන්මයි ඉලෙක්ට්‍රෝන ගැලවිලා ගියේ. එතකොට මේකේ ලෝහයේ තියෙන ධනාරෝපණය සහ ඉලෙක්ට්‍රෝන වල ඍණාරෝපණ සමතුලිතයි. ඒ හින්දා මේක neutral. So this is neutral. There is a positive if the metal rod contain n number of electrons, it have n number of positive charge also. We know that. That's the definition of metallic lattice. So this metal rod is neutral initially. However, this metal rod contain free electrons. මෙයාගේ free electron තියෙනවා. Because of that, the metal ion come from the solution. Metal ions come from the solution will form a bond with electrons from the rod, and it will form M solid. So the metal ions in the solution will get 2 electrons from this, or n number of here n number of electrons, not 2, get n number of electrons from this rod, and it will deposited on the surface of this metal rod. It will deposit. This is the first reaction, the possible first reaction. What is that? The ions, metallic ions from the solution will get, here should not 2, it should be N. If we consider this type of reaction, copper 2 plus, Cu2 plus get 2 electrons, and it will deposited as copper solid. Here this is 2, it is oxidation state. So here it should be N. Mn plus ions in the solution will get n number of electrons from the rod, and it will form M solid, and it will deposited on this electrode or metal rod. So this reaction is happening in the interface. In this interface, this reaction is happening on this interface, metal and aqueous interface. There are 2 phases. No, this is solid phase, this is liquid phase. So in between these 2 phases there is an interface. This reaction will happening in this interface, on this interface. So this is the first possible reaction. What will be the second possible reaction? There is another reaction also. What is that? The metal rod, we know metal rod contain equal number of positive charges and equal number of negative charges, but those are free. The metal ions are free and electrons are free. What will happen if the metal rod containing the metal ions of the rod will come to solution as Mn plus? What is the second possible thing? The free cations of this metallic rod will come to the solution. When they coming, what will happen? The neutral rod will not be neutral further. Initially, equal number of metallic ions were there according to their electrons. මුලදී ඉලෙක්ට්‍රෝන ගානට සමාන කැටායන ගානක් තිබුණා. හැබැයි දැන් මොකද වෙන්නේ? මේකෙන් Mn මේකෙන් එයාගේ කැටායන් එකක් එළියට ආවා කියන්නේ ඊට සාපේක්ෂව ඉලෙක්ට්‍රෝන ප්‍රමාණය වැඩි වෙනවා. When metallic ion come out from the rod, what will happen? The negative charge will be increased, because to neutralize excess electrons there are not any there is no sufficient amount of cations. Because of that, what will happen? I will enlarge this situation and I will draw it here. The interface, this is your rod, Okay. This is the beaker. This is the solution. This is your rod. What will happen? In first situation, Mn plus of this solution will get n number of electrons from this rod and it will deposit on the rod. That's the first thing. What is the second thing now I am explaining is, the metal contain free cations and the metal rod contain equal number of electrons also. If the cation is Mn plus, the metal rod should contain n number of electrons. So when this metal ion come out as Mn plus, what will happen? To neutralize these two electrons, there is no sufficient amount of cations because now it come out. What will happen? Negative charge will develop in this rod, in this situation. Okay, that's the thing. Okay, so negative charge will develop on this metal rod compared to this solution. So that's the second thing. This metallic rod will dissolve or it will lose n number of electron and will form Mn plus. This is aqueous, this is solid. So initially we know the concentration of Mn plus in this solution is lower than the rod. Rod එකට වඩා මුලදී solution එකේ තිබ්බ ලෝහ ප්‍රමාණය අඩුයි. ඒ නිසා the possible or favorable reaction is this reverse reaction. So this is the possible or fast reaction. This will happen very quickly because initially the Mn plus concentration in the solution is lower than the rod. So this reaction is number one, priority number one. Because of that, metal will lose its electron or keep its electron on the rod and it will come to the solution. Because of that, rod will be negatively charged. To compare to that, compare to the rod, the solution will have large number of cations. Large number of cations. That means if the solution contains large number of cations, what will happen? So this backward reaction, this backward reaction, Mn plus formation from M is depend on the concentration of cations. So after some time, the solution will get sufficient amount of Mn plus cations. So this first reaction, so this fast reaction will be slowed down. Okay. On the other hand, this first reaction also happening. However, in some time, after some time, very small time interval, this will be reversible. This equation will be reversible. So both forward and backward reaction will be, their rates will be equal. Here R1, here R2. R1 will be equal to R2 rates after some time. At that time, we can see a good separation of charges. Metal rod will be negatively charged and to compare to that, the solution will be positively charged. We can clearly see a charge separation in this reversible situation or equilibrium. This is called equilibrium. What is going on? After some time, this reaction will be reach into an equilibrium. So in this situation, this system. So this system will call, initially this system is calling electrochemical system. Electrochemical system. So this is equilibrium. Electrochemical system. After some time it will be reached to an equilibrium. At that time it will be equilibrium electrochemical system. At that time we can see a permanent charge separation of these interfaces, solid and aqueous phase. At that time we can see a voltage difference in this, or potential difference of this both interface. So we call that equilibrium voltage or equilibrium potential difference. Actually it is equilibrium This is called equilibrium potential difference, because initially what happened, this reaction is the common reaction. Mn plus from the solution will get n number of electrons from the rod, and it will form metal and it will deposited on the surface or interface of the rod. It is the forward reaction. Backward reaction is this metal of the rod will lose its n number of electrons and keep that electrons on the rod, and metal ions come to the solution. That's the second reaction. So second or backward reaction is the priority reaction. It will happen very fastly, because initially metallic concentration of the solution is lower than the rod. So this backward reaction is the possible or priority reaction or prominent reaction. So after some time, the rate of forward reaction and backward reaction will come to an equilibrium. So at that time we call that it is in an equilibrium. So at that equilibrium we can see a permanent charge separation or clear charge separation. Clear charge separation. At that time we call that charge separation as equilibrium potential difference. Actually that is the electrode potential. This is the electrode potential. So this system is called electrochemical system. Okay. Electrochemical system consists of solid phase metal rod and its ionic solution or electrolyte solution. Okay, solid and aqueous, two phases are there. If someone asks you what is an electrochemical system, so you have to define metal rod dipped in its own ion containing solution or electrolyte solution. So that system called electrochemical system. Electrochemical system should have two phases. One is solid. That solid phase known as the electrode. This is electrolyte. So you have to know these things. Okay, these are the basic theories and electrode potential. This is how the electrode potential is formed. Okay, now how can we measure this electrode potential? That's the next thing. Let's go to that theory. Okay, now we know what is an electrode potential. A metal rod dip in its own ion containing solution or electrolyte solution. Here M, here Mn plus. There are two reactions, forward and backward. Backward reaction is the priority number 1 or favorable reaction. After some time, the rate of the forward reaction and backward reaction will be same. It will goes to or reach to an equilibrium. We call that equilibrium potential difference form in between these two interfaces. Metal and solution, there is a permanent charge or clear charge separation. We call that charge separation. Because of that charge separation, there will be a potential. So that will be equilibrium potential difference. We call that electrode potential. So how can we measure this electrode potential? There is no option actually. Automatically in nature we can't watch, we can't see the potential difference. So to measure this difference, we have to use another electrode. With the aid of another electrode, we can measure this electrode potential. So as a standard situation, so to measure this electrode potential, we use standard electrode called standard hydrogen electrode. What is that? In standard hydrogen electrode, this is the structure. Solution containing H plus, this is a platinum rod or platinum electrode. Bottom of that platinum electrode contain platinum plate. Here platinum plate. So this platinum plate is coated with platinum black. සම්මත හයිඩ්‍රජන් ඉලෙක්ට්‍රෝඩ් කියන්නේ මෙහෙම ප්ලැටිනම් ඉලෙක්ට්‍රෝඩ් එකක් තියෙනවා. ප්ලැටිනම් ඉලෙක්ට්‍රෝඩේ යට තහඩුවක් තියෙනවා. තහඩුවට ප්ලැටිනම් දැලි ආලේප කරලා තියෙනවා. Okay, this solution contain H plus and we will pump hydrogen. We will pump hydrogen. We will pump hydrogen to this system. Hydrogen pump. Excess hydrogen will goes from this tube. So we supply hydrogen gas. Solution contain H plus ions. This is the standard hydrogen electrode. What is the meaning of standard? This in standard situation we have to know these conditions. If we consider standard conditions, standard there should be a pressure, standard pressure. The standard pressure is 1 bar. Okay, the standard temperature is 25 Celsius or 298 Kelvin. The standard temperature. And also we have to use the concentration as concentration should be 1 mole per cubic decimeter. These are the standard conditions. So this electrode should be in standard conditions. H plus concentration should be 1 m. Okay, the temperature of the system should be 298 Kelvin and the pressure of this hydrogen supply should be 1 bar. Or atmospheric pressure should also be 1 bar. So to apply this hydrogen electrode, our electrode should be in the this standard conditions. So the concentration of these Mn plus ions should be 1 m and temperature of the system or should be 298 Kelvin, and here we are not using a gas. If we are not using a gas, the pressure is not considered in this situation. We really have to consider this pressure if we are using a gas. Only if we are using gas, we have to consider about this pressure, except in solid and liquid phases we are not considered the pressure. Other two parameters, temperature and concentration, should be in the standard situation in this liquid and solid containing systems. However, if you are using a gas, you have to consider pressure also. Okay. Now, by using this standard hydrogen electrode, we can measure using a salt bridge and using a particular instrument, the electrode potential of this our own electrode. So that potential we call standard electrode potential. So this hydrogen electrode is known as reference electrode. Reference electrode, because we can't measure electrode potential of a particular electrode without using an other electrode. That electrode should be hydrogen electrode. In next video I will explain the electrochemical series or reactivity series. To build up this reactivity series, always we have to use hydrogen electrode as the reference electrode we have to use. So in standard situation we consider the potential of hydrogen electrode is 0 volt. E theta, electrode potential, standard electrode potential is 0 in hydrogen electrode. With compared to this hydrogen electrode, we can measure the potential of our cell. So this is the when we get a value with compared to this standard hydrogen electrode, that potential called standard electrode potential. මොකක්ද අපි කියන්නේ? අපි සාමාන්‍යයෙන් හදාගත්තු අපේ ඉලෙක්ට්‍රෝඩේ මොකක් හරි ලෝහයක් එයාගේ අයනවල ගිල්වලා හදාගත්ත ලෝහයේ අදාළ ඉලෙක්ට්‍රෝඩ විභවය අපිට හොයන්න බෑ නිකන්. එයාට වෙනම කෙනෙක් එක්ක සංසන්දනය කරලා තමයි හොයන්න බලන්නේ හැම වෙලෙම. මොකද මේකට මේ දෙන්න ඔටෝමැටිකලි අපිට පේන්නේ නැහනේ. මොකක් හරි ඉන්ස්ට්‍රුමන්ට් එකක් යූස් කරන්න. ඉතින් අපි යූස් කරන්නේ හයිඩ්‍රජන් ඉලෙක්ට්‍රෝඩ් එක තමයි මෙයත් එක්ක පාවිච්චි කරන අනිත් ඉලෙක්ට්‍රෝඩ් එක. හැම වෙලෙම සම්මත හයිඩ්‍රජන් ඉලෙක්ට්‍රෝඩේ තමයි පාවිච්චි කරන්නේ මොනම ලෝහයක සම්මත ඉලෙක්ට්‍රෝඩ් පොටෙන්ෂල් එක ඉලෙක්ට්‍රෝඩ විභවය හොයන්න. ඉතින් හයිඩ්‍රජන් ඉලෙක්ට්‍රෝඩේ සැකසුම තමයි මේ සම්මත තත්ත්වයට තියෙන්න ඕන. සම්මත තත්ත්ව කිව්වේ පීඩනය 1යි බාර් වෙන්න ඕන. උෂ්ණත්වය සෙල්සියස් 25 නැත්නම් 298යි කෙල්වින් වෙන්න ඕන. එයාගේ සාන්ද්‍රණය ඝන දෙසිමීටරන මවුල එකක් වෙන්න ඕනේ සොලියුෂන් එක. මේවා තමයි සම්මත තත්ත්ව. සම්මත තත්ත්වයට තේදී අපි මනින අපේ විභවයට කියනවා සම්මත ඉලෙක්ට්‍රෝඩ විභවය. Initially it called electrode potential. However, after we using reference electrode, hydrogen electrode at the standard conditions, we call that the standard electrode potential. That's the definition of electrode potential and the standard electrode potential. So I think you got a clear idea about this. So in next video I will explain you about reactivity series or electrochemical series. Okay. So clearly draw this sketch and clearly get the idea, and I will if you have any question, please leave a comment and please subscribe my channel. Thank you for watching.